All right. Okay. So yes, they have the same base. Going to add the exponents, so that's going to be x to the 2/7 plus 1/3. Okay. Am I ready to add those exponents? No, because way back when I learned what must be true in order to add fractions.
They have to have a common denominator.
Common denominators. What's a good common denominator for 7 and 3?
21.
21. So we'll multiply 2/7 by 3/3. So that'll be x to the 6/21. And then we'll multiply the 1/3 by 7/7. So that we'll have plus 7/21. And then that comes out to be x to the 13/21. Now, I can't really evaluate x to the 13/21 because I don't have a number there. And like really when you think about it, I'm probably not like on a quiz or a test going to give you something where you have to do like a 21st root of something. Okay, that would have to be like a very large number. If you want to type in 2 to the 21st in your calculators, I think it's like over 2 million. Okay, but you would use if I give you a 21st root, you would use that root button on your calculator, right? Okay, but I'm probably not going to ask you to do one of those. All right? Okay, what are we going to change about our directions for quotient of powers when you are dividing two powers? Yeah, you guys already know this. You end up subtracting your exponents. You keep your base. That one's hard to do sometimes when we have these numbers. Can you imagine? Some people are going to do 5 times 5 and get 25. Okay. Some people are going to divide right here, 3 divided by 3 and get 1. Okay. We're going to do those things when we're not paying attention. And so we're going to keep the base. And of course, again, in order to be able to do this, we first have to have the same base. Okay. So A is a good one for us to look at because we have 3/3 to the 1/2. And usually when I get something like this, I get a lot of people who cross out 3's. And they just make it 1. But what you're doing there is you're dividing before doing an exponent, so you're violating PEMDAS. That 3 in the numerator has an exponent. What is the exponent of 3 up there? It is 1. So now I can see them as both powers that have the same base, but they have different exponents. And I can divide them by keeping my base and subtracting my exponents. Where are there more 3's? In the top or in the bottom? Like, where is the exponent bigger? In the top. So when I choose to subtract, I can subtract top minus bottom, and I'll get a positive exponent, and it'll stay up in the top. So it'll be 3 to the 1 minus 1/2. And if you wanted to play the game of getting common denominators, you could. But I am pretty sure most of us can subtract 1 whole minus 1/2. It is 1/2. Okay, so this is really 3 to the 1/2. You know, like you could do 1 minus 1/4. It's 3/4. You don't really have to get common denominators to do that subtraction. But if you need to, you can. Okay. I might stop and think about 3 to the 1/2. Like, even if I don't write it down, I'm thinking about the fact that that's the square root of 3. Okay. Either answer is fine. 3 to the 1/2 or the square root of 3. But the square root of 3 doesn't work out nicely, so I can leave it alone if I want. Okay, that's just my thought bubble, right? I'm thinking that in my head. I don't have to write it down. Either one is fine. Okay, let's look at B. Of course, B is going to be one of those where, do they have the same base? Yes, and they are powers that are being divided. So what should I do with my exponents? Subtract them. What issue am I going to run into when I try to subtract these two fractions? They don't have common denominators, so I'm going to need common denominators. you can decide, like, when do you want to get common denominators. I'm going to go ahead and do common denominators right away. So this is y to the 3/8 divided by y to the 6/8. Excellent. We're multiplying by 2 over 2 to get a denominator of 8. And then I can say I'm going to subtract my exponents. Now, this should be something you practice back in Algebra 1, but I always say, like, where are there more y's? Like, which exponent is bigger? 3/8 or 6/8?
6/8.
6/8. There's more y's in the bottom. So really, if I wanted to subtract and I wanted to have a positive exponent, which I do, I can subtract like 6/8 minus 3/8. But because that one is in the denominator, that means that's where my y is going to end up being, in the denominator of a fraction. What will be left in my numerator? A 1. Just like a placeholder to say that y to the 3/8 that I'm going to get when I subtract my exponents, that's not on the regular line of text up in the numerator, that's down in the denominator of a fraction. Okay? So the correct answer here would be 1 over y to the 3/8. Now, you might have chosen to just do your subtraction right away. Y to the 3/8 minus 3/4. That's y to the 3/8 minus 6/8, which is y to the negative 3/8. And we're going to do this property here in just a minute, and we've already talked about it on Friday. You don't actually want to leave a negative exponent in your final answer. So negative exponents flip what they touch. It's touching the y, so the y would flip down below. And that's going to give me the same answer, 1 over y to the 3/8. But I kind of like to get my common denominators first and just figure out, like, where are there the more y's, which exponent is bigger, and then when I subtract, I just either keep it in the numerator or keep it in the denominator. If everything disappears from your numerator, then you put a little 1 there. Does anybody have any questions about that? Okay, so we've covered adding and subtracting exponents with product of powers and quotient of powers. So the next one on the list is the power of powers. So essentially you're taking a power and you're making it into a base and giving it a new exponent. So it is a power. Again, what do you do with your exponents then? Multiply. So we're going to multiply exponents. And we're going to keep the base. So 7 to the 2/3 raised to the 5/2. I'm going to rewrite that so I can see it a little bit better. Okay, just a quick review of fractions. You can do this 2 ways, and you're going to get the same right answer either way. When multiplying fractions, you do not need common denominators. You can just multiply across on top and get 10, multiply across on bottom and get 6, and then 10 over 6 reduces by 2 to be 5/3. Okay? Or you might look at your 2 fractions and check to see if anything cross cancels. A 2 in the numerator will cancel with the 2 in the denominator. They both turn into 1s. 2 over 2 is really 1 over 1. And then again, just multiply across on top. 1 times 5 is 5. 3 times 1 is 3. So 7 to the 5/3. Okay? If you don't like cross-canceling, then you just multiply across on top. Multiply across on bottom. Simplify. If you don't like simplifying at the end, try to cross-cancel before you multiply. You can leave it like this, or if you want, like you're practicing those flashcards, isn't that really the cube root of 7 raised to the 5th? But I don't know the cube root of 7, so that I would just leave it like that as well for an exact answer. Either one is Okay, what do you get when you do x to the square root of 3 times the square root of 3? That's not a fraction exponent, it's an irrational exponent. But still, the rule is the same. It's just x cubed. It's x to the square root of 3 times square root of 3, which is x cubed. So it doesn't matter if it's integer exponents, fraction exponents, irrational exponents. Okay? The rules of exponents are always the same as what you learned back in Algebra 1. So I'm not really throwing anything new at you. Okay, and then just in case these show up in your work, you need to know what to do with zero exponents and negative exponents. Does anybody remember what happens when you raise something to the zero? It equals 1. We saw that with Pascal's triangle, didn't we? Okay, so anything raised to the 0 is equal to what? So if in the middle of your work you come across something to the 0, then just simplify it, make it 1. Essentially, you can think about it like it disappears, right? Because 1 is the identity. You multiply it. So like in this one, z to the 1/5 times z to the negative 1/5. Same base. Multiplying powers. So I should add my exponents. That gets me to z to the 0. Which I would then simplify as just 1. Doesn't matter what z is, it's always going to come out to be 1 in the end. Negative exponent property, we talked about this on Friday. If you've been listening to me, I've probably said it about 25 times already. Negative exponents don't make things negative. So just because you have a negative exponent does not mean your answer is negative. Negative exponents flip what they touch. Okay? So I just say negative exponents flip what they touch. Essentially, I mean, the math word for that is reciprocal. Okay, that you're turning the base into its reciprocal. If it's in the numerator, it moves to a denominator. If it's in a denominator, it moves to a numerator. Okay, it just goes in the opposite place. Negative exponents don't make things negative. I cannot say it enough. I'll probably say it 100 more times before this chapter is out. And when you see on your quizzes and tests that you made a negative exponent turn it into a negative, you're going to have that palmed forehead moment. Okay, you knew it wasn't true. Okay, so you might have seen something like A on the flashcards you were doing at the beginning of class, right? 8 to negative 1/3. There's many different orders that you could take for this. I usually always, because that negative seems to be troubling, I always do the flip first. So I'm going to flip it. Instead of being 8, it's going to be 1/8. And then as soon as I flip it, then the exponent becomes positive. So it's 1/8 to the 1/3. Because the negative exponent just flips the base. And then if I have a 1/3 exponent, that's like taking a cube root of 8, which the cube root of 8 is 2. So negative exponents don't make things negative. If they have integer bases, whole number bases, they make them fractions. If it's a fraction and you have a negative exponent, it might make it into a whole number or an improper fraction. Okay, and then B, I like, Alex, it kind of goes with the question you asked about that formula on the homework. This is where, you have to pay attention to what exponents are touching what. So, when you look at B, you have 3 powers, but they all have different bases. So I can't use product, quotient, or power of a power. Okay. But I do see that there are negative exponents, so that answer is not in its simplest form. Since z has a negative exponent of 1/4, it's going to move from the numerator to the denominator. And in the denominator, y to the negative 2/3 is going to move from the denominator into the numerator. What happens to x to the 4/3? It stays where it is. I get a lot of people who try to move the x like as if it's attached with the z because they're being multiplied. But remember, that's the whole thing about Alex's question, like, what is the negative 1/4 touching? Z only. So it only flips z. The correct answer here would be x to the 4/3, y to the 2/3, z to the 1/4. If you wanted to change them to radicals, that's fine, but since I know I'm not going to be able to evaluate with variable bases, I'll just leave it alone. So don't get caught up thinking, oh, I see negatives, everything flips. Only the things that the negatives are touching are going to flip. Anybody got any questions for me on properties of exponents? Should all be review. Nothing there is new to you. Okay, and we've used those properties when we've been doing Pascal's triangle, multiplying, adding, polynomials in chapter 4. So the only thing new is that they have fraction exponents. Okay, you have some time to get started on the homework assignment. And notice it isn't really very bad. It's page 248, numbers 3 through 12, and then also 63 to 64.